let's look at the built-in functions of set. So as you know, set is a collection data type in Python which doesn't allow duplicates and which is not ordered as well. So let's look at the built-in functions of a set which contains a series of integers here. So this is one of the ways of defining the set, and then we have all these duplicates that are automatically removed. So I had the duplicates 78. Now, what are the built-in functions? There are two categories of built-in functions of a set. One is the built-in functions that are related to the data type manipulation. The other is the built-in functions that are related to mathematical set theory related functions, right? So we can classify this under two heads. So one is related to the collection data type manipulation. The other is related to the uh, set theory mathematical functions. So let's look at there are totally 17 built-in functions of a set. So let's look at only the data type manipulation functions in this video. So you can actually find out about the built-in functions by in the Google Colab by using the shortcut dot and then tab. So here you can see all the built-in functions. Similarly, if you are using a Google Colab and then Jupyter Notebook, if you just scroll your mouse near that, so you will get all these functions as well. So let's look at how you can add value to the set. So just say name of the set good set dot add. So 25 gets added, but as you can see, uh, it is not ordered. See, the order in which you have inserted the element is not reflected in the order in which it is output. So sets are unordered. So you can also copy the given set to another set. So you can see that it's copied. So another interesting function for the data manipulation, collection data type manipulation is clear. So it clears everything. So as you can see, if you run this, it completely clears that. And then I copy it back from the variable that I created to the original good set variable. So so first here I copied it to another variable which is called new set, and then I cleared the good set. It became null, and then I copied it back to this good set variable. So we are back to the place where we started. Uh, Another important difference between the built-in functions that are used to remove an element from a set. There are two functions for this. One is discard and the other is remove. So one key difference between the discard function and the remove function is the discard function. If you give an element which is present here, it will remove it. So that's straightforward. But if you want to discard a element which is not present in the set, so what happens is the discard function doesn't do anything. So it just leaves the set as it is, and you see it returns none. So if you discard an element that is not present in the set, it leaves the set as it is and it doesn't return anything if you use discard. But if you use remove and then you want to delete an element that is not present in the set, then the remove built-in functions gives an error. The remove built-in function gives an error saying that there is a key error 29. The key value that you are giving is not present in the set, is not present in the set. So that's an interesting difference between discard and remove. And of course, if you give an element that is present in the set, both of them will remove. The difference is only when if you don't give an element that is present in the set, discard doesn't give any error, whereas remove gives an error. What about update? So you can actually update the original set with another uh, two or three values at a time. So you can update with 2, 3, 4, and you can also update with 4, 5, or You can give a set of values, or you can give 45 and 56, but it actually converts it into single values and keeps it, right? So uh, you can you can give these values, but it takes them as individual values when you give it to update, right? So this is a key difference. This is a key difference uh, with respect to the list and the set, because when you update, it converts it into individual elements. But an interesting thing is, when if you don't use update, if you use, for example, let's say set1 is equal to this, and then you give a tuple, so it will take a tuple, it'll it'll take a tuple, and then it'll print set1. The reason is tuple is immutable. Tuple is immutable. So it takes a tuple. Similarly, it can also take a frozen set, but it cannot take a dictionary or a list or a normal set. When you give a dictionary or a normal set, it then takes it as it's an error. It's an error. But if you give it with update function, then it splits it into individual elements and then takes it. But if you give it as part of the original definition of the set, then only tuple and frozen set are allowed as elements, because uh, tuples and frozen set are hashable since the object is immutable. And probably one thing we can see is the pop. So you can see that when you pop this, so I have this set, and when you pop an element, it actually takes out this one. The first element that is present in the set is taken out, and then the rest of the set is printed here. So that's the pop value. So it's actually equivalent to remove, but only thing is it actually removes the first element in the set, which is the pop. So we have seen in this video all the data manipulation built-in functions of the set collection data type. The other video that talks about the data manipulation mathematical functions of the set is available in the video. Please click on that link to watch the other video. Thanks for watching.